Hi class, this is Professor Dave, and this is a lecture on unexpected value. We're going to cover these things. We're going to cover probability distribution and a couple examples with that. The key thing is expected value with standard deviation, and that's really a weighted average. We're going to do a couple of examples with these, a basic one with dice, then two very real ones, roulette and lottery, and then a couple of examples with the TI-83. Okay, so first off, a random variable is just a variable that's random. Okay, a variable whose outcome is determined by chance. And here's a couple of examples. X could be the number of car accidents in Santa Clara in a given day. We don't know how many car accidents are going to be. After the day unfolds, we'll know. But a priori, we don't know. So it's a random variable. The number of sixes that come up in 25 rolls of a dice, right? The number of defective parts in 100, or the S&P return on a given day. Okay, so let's see. And then a probability distribution just gives the probability for each possible value of the random variable, and we'll see examples of that. Now the notation is a probability that the random variable takes on a specific value. X is just equal to this. All probabilities are between 0 and 1, and the summation of all probabilities has to equal 1, as in, i.e., something must happen. Okay. Okay. So expected value, the big picture. The expected value allows you to make intelligent decisions in the face of uncertainty. It allows you to determine when to gamble, how much you should pay for insurance, should you drive, take a plane, etc., or how to invest your money. It's very key for a whole bunch of things. I feel it's the strongest piece of mathematics there is out there. Okay, so expected value is actually pretty simple. It is really just the the summation, there's a summation sign, of all the values x's times the probability of those values. And we'll see plenty of examples with that. But that's what it is. You expect to get, well, we'll see. Now, it's really like a weighted average. Now, with exam scores, okay, say you had the following exam scores. You had a 75, an 82, a 92, and a 95. And you wanted the average of that. Well, to get that average, you just sum them all up and divide by 4, and you have an 86, a nice solid B, so good job. Now, but say we wanted to give the weights as, well, maybe the first exam it's 10% and 20% and 30% and 40% for the fourth exam. Now, these weights sum up to 100%, so that makes sense, right? So the sum is equal to 1. And how do we do a weighted average? So the weighted average is really just expected value. It's the weights times the value of those weights times the values. So in our case, we have the weight is 10% times the first exam times 75, 20% times 82, 30% times 92, and 40% for the final, say, the 95. If you do that multiplication, you get an 89.5. Still a B. But if you had me for a professor, I do look at how you did on the final. You got an A on the final, and that's close to, that's rounding, so I would round up to an A. Hooray. So good job. Now, the original average, you sum all up, divide by the number, is really a weighted average too, but the weights are the same. Right? We distribute that 1/4 amongst the 4 values here, distribution rule. And we really have the weight as 1/4 times each of these. So the average, the expected value is really calculated the same. It's just that the weights are the same. So pretty cool. So that's how you calculate a weighted average, and you can use that. But it's also an expected value. Okay. The key thing is that the sum of the weights must be equal to 1, and that's the case, just as before. So let's do an example. Playing cards. Rolling a die. Okay. So you roll a die, and if an odd number comes up, you win that amount. If a 2 comes up, you win $1. If a 4 comes up, you win $1. You lose $1. But if a 6 comes up, you lose $8. So you don't want a 6. Now, would you play that game? How would you determine that? What's the expected winnings on a single play, and what about 100 plays? So this is exactly how you would determine whether you would play a game, the expected value. Okay, so let's do it. So let's just set up a table, right? The event is rolling the dice, 1, 2, 3, 4, 5, or 6. You have the winnings, $1, 3 gives you $3, 5 gives you 5. You get a 2, you get $1, a 4, -1, and a 6, a -8. Now, what's the probability of each of these events happening? Well, 1 out of 6 each time. So we just do the winnings times the probability of those winnings, and we get these values, and then we sum them all up. So basically, we did an expected value of the winnings times the probability of those winnings. You win $1 because a 1 comes up around 1/6 the time. You win $1 because a 2 comes up around 1/6 the time. You win $3 because a 3 comes up around 1/6 the time. You lose $1 because a 4 would come up around 1/6 the time. You win $5 because a 5 comes up around 1/6 the time, but then you lose $8 because a 6 comes up around 1/6 the time. So we have a nice straight average, which is equal to 1/6 if you added that all up, or round it to about 17 cents on average per dollar bet. What about if you play 100 times? Well, you'd win on average $100 times 17 cents would be about $17. Since that's really 1/6, it's really $16.67 on average. So that's how you do a weighted average and an expected value. So we would play this game. In fact, we would set up computers that play it all the time and make a bunch of money, but the other people wouldn't do it because they're losing money, so it just wouldn't happen on a large scale. But playing your friends, you can win a little bit of money. Okay, let's apply that to where they do set things up on a big scale. Roulette in the casinos. Okay, well, you can expect, so let's say you bet that $1 comes up, well, what is roulette? Okay, so roulette is you take this ball, it goes spinning one way, and they spin this wheel another way, and it bounces all around. They got these little bumps here, bounces all around, and it lands in one of these little square boxes that correspond to numbers either 1 through all the way through 36, and a 0 and a double 0. We got a 0 here and a double 0 over here. So that's a roulette table. You can put coins anywhere, or not coins, but chips anywhere. You can bet on the number 19. You can bet on the second set of 12, which would be 13 through 24. You can bet on 1 through 18. You can bet on even. You can bet on red or black, and you can bet on this entire row here, by putting a chip here, etc., etc. So let's analyze one of these. Okay. So there's numbers 1 through 36 plus a 0 and a double 0. You bet $1 that even comes up. You win $1 if it comes up even, and you lose if it doesn't. What's the expected value for this? If you play 100 times, how much would you expect to win or lose, and what is the standard deviation on a bet? Okay, so what's the expected value? That is, how much would you expect to win or lose on each play of $1 on average? Okay, now a mega analysis of it would be that, well, they have casinos and they're making money and paying a whole bunch of people, and they have a stock exchange, stocks on the stock exchange, and so they're making money. So people are probably losing money, and there you go. That's good analysis. But let's look at the numbers. Okay, so let's set up our event table. We got even and not even. It's not odd, right? Not even, because we have zeros and double zeros. If it comes up even, we win $1, and how many of those do we have? Well, we have the numbers 1 through 36, so half of those would be 18. You can add them all up. Okay, 18. And so 18 of those. Now, how many are not even? Well, we have the 18 that are odd, plus the 0 and the double 0, so there's 20 out of 38. That's the house edge, the 0 and the double 0. Okay, so let's do the expected value. It's just the winnings times the probability of those winnings. We win $1, 18 out of 38 on average, because each of the even numbers will come up on average once out of 38 times. So it's $1 for that. Then we'll lose $1 for 20 out of 38, because all the odds will come up and the 0 and the double 0 will come up on average every 38 times. It won't happen every 38 times, but on average for a long period of play that will happen. So if we add these up, it's clearly minus 2 over 38, or minus about 5 cents per dollar bet each time you play. And that's it. On average, you'll lose 5 cents per dollar bet, and that's the game. I can't play these things because I know exactly what's happening. Sometimes I go in, I watch people play, and I realize they don't know math. Okay. Now, what's the standard deviation? The variance of standard deviation is just the expected value of the value that comes up minus the mean squared. That's the definition. And that's the summation of all the x's minus the mean squared times the probability of those x's. And the standard, that's for the variance. The standard deviation is just the variance square rooted. Okay? Or the variance is the standard deviation squared. That's really how it's said. All right, so let's calculate it. So we have this formula. We have the weights, the winnings minus the mean squared times the probability of that. So our mean is a negative 0.053. So we win $1, and we subtract off the mean over negative, square that 18 over 38. That's the probability of winning. Probability of losing, we lose $1, so minus 1 minus the mean, which is a negative this, square that, times 20 out of 38, the probability of losing. So our average is very close to 1, or the variance turns out to be very close to 1. So we take the square root of that for the standard deviation, even closer to 1. So standard deviation is about 1. Doesn't matter too much, just wanted to show you the calculation. Okay, next example, play lottery. Alright, so we pick 1 through 47, and we have to get the number of these right. Pick 5 numbers from this and see if you get them all right. Okay. So let's just say we get all 5 for the mega jackpot. Our probability of the odds of winning is on these numbers here, and we get to win. If we get it all, we get 10 million here, we get this amount here, we get all these for the different things. So then for the different ways of winning. So then what's the expected value? What's the value of a lottery ticket? Right? What's the value of the lottery ticket? Well, we just have to set up the event table, the winnings times the probability of the winnings, and sum them all up. And I did that in Excel. So here we are. We just put those odds numbers in here, and then the amount that you win, the probability that you win, which would be just 1 divided by this number. 1 divided by this number. This row is C. Okay. Then the probability of winning is just that. It is just a formula in Excel how to do it. These are the actual numbers. You take this number times this number. You get these numbers here, and then you sum them all up. You sum up all these numbers, and you get the expected value is about 43 cents. So you're paying $1 for a lottery ticket, and it's worth about 43 cents. But you get this very small chance of winning a large number, and that's why people do it. But the expected value is 43 cents. So lottery folks are, they collect in $1. They have to pay out 43 cents in payoffs to people who win, those they collected. And then there's administrative costs and everything, and then the rest is revenue for education and things like that. And perhaps I should be educating about lotteries, but okay. So very, very small chance of actually winning. I don't play the lottery because it's not worth my time to see if I won. And so a lot of people who won the lottery are not happier. So that's why I don't play. Anyway. Okay, so let's do a couple of examples with the TI-83 calculator. Alright, so say we have the number of cars sold per car salesman on a given day, and so the probability, so X is either they sell 1, 2, 3, 4, or sometimes you get really lucky and sell 5. And the probability for that is probability of selling none would be 10%. Selling one, 35%. Most likely they'll sell 1 car a day. Now these numbers I just made up, so I don't know, but it's an example. 2 cars about 25%, 3 cars 15%, 4 cars 10%, and 5 cars 5%. So that the salesperson and the sales manager can plan, right? You want to know how much they're going to make on average in a day, and the company wants to determine how much they make on a given day. So how many cars are they going to sell on average? Okay, so let's pop over to the calculator, and okay, so here's our calculator, and let's just punch in the numbers. So we turn this on. Okay, and so we go into stats and edit, and let's go to list 1. So we have to punch in the values for X first. So we put in 0, enter, 1, enter, 2, enter, 3, enter, 4, enter, and 5, enter. Okay, because we have a 5 over here of 5%. And now we put the probabilities in the second one. So we put 0.1, enter, 0.35, enter, 0.25, enter, 0.15, enter, 0.1 for number 4, and 0.05, right, for number 5, and 0.05. Okay, so that's entering the numbers. Then we hit stats again. We hit stats right here, so stats, and then we go to calculate, so we move one over, and we want the one variable statistics, so we say enter. And this is a key thing. We just put it in list 1 and list 2, so we have to put L1 comma L2. So we go hit the second button, second for L1, so 1, and then we hit this comma button and we want to put L2 in, so second L2, and we hit enter. And we got a mean of 1.95. So on average, they'll sell about close to 2 cars, a little bit less on average. And the standard deviation comes up right here, 1.32. Okay, so the mean was 1.95 and 1.32, and that's how you do it on the calculator. Let's do another example. Okay, best of 7 series, like a baseball series. Suppose that there's a 22% chance that the series ends in 4 games, and a 32% chance it ends in 5, 27% ends in 6, and 13% chance it ends in 7. So this is a probability distribution, and find the expected number of games on average and the standard deviation in that number. Okay. So we just had to add up these probabilities. Does it add up to 1? So yes, it's a probability distribution. Okay. And for the second part, okay, we just have to add them into our lists. Okay, so we go to stats and edit and enter. Now we have numbers in here, so we can clear them. So go up to here, say clear and enter. And let's just clear this one too. Clear and enter. Now we just have to put the numbers in, all these appropriate numbers. So let's move this over to this side so we can see them all. Okay. All right. So we have the values 4, because it ends in 4 games, 5 games, 6 games, or 7 games. Okay. And then we have the probabilities. 0.22, enter. 0.34, enter. 0.27, enter. And 0.17, enter. Okay, and now we just do that same thing. So we go stats, calculate, single variable statistics, and we put L1 and L2 in, so second L1, comma, second L2, enter, and we get a mean of about 5.4 games, so somewhere between 5 and 6 games is the average. Okay, and the standard deviation turns out to be basically 1.001. So there we have it. So this is the standard deviation, that's the mean. Okay, so The mean, again, we can do it by hand, even 4 times this and 5 times that and 6 times that and 7 times that, 5.5. And the standard deviation was equal to that 1, basically. So 1. Okay, so 1. Okay. Okay. One more example. Insurance. Suppose that you're interested in providing life insurance to your family. Suppose that your insurance costs $250 for a $50,000 policy, and you're 40 years old, healthy, exercise, you eat well, you're good to other people, and you give to other people, and so you know, a good lifestyle, and so your chance of dying is pretty low, say 1 in 1,000. Find the true cost of the policy to the company, the expected value, and how much they're making. And then find the standard deviation in that number. Okay, so the expected value is just the x's times the probability of those x's, right? So we can say it's 50,000 times the probability of dying, that's how much you would get back, minus $250 times the probability of not dying, right? So the expected value here is almost a negative $200, so that's how much the company is really making on the deal, because there's a small chance that they'll pay out 50,000, but otherwise they're collecting 250, and that goes for the coverage of the insurance company, paying employees and all that, and hopefully they're not making too much. Okay, so what's the standard deviation? Well, it's a little harder to do. We might as well just do that on the calculator. Okay, so let's pull up the calculator again. Now I put these numbers in here this time. Now let's go to edit. Okay, I just wanted to show you one other thing. Okay, I put the numbers in L5 and L6. Okay, I just scrolled over to L5 and L6. So I put 50,000 minus 250,000, 0.001, and the complement of that, 0.999. All right, and that's how I got this number as well. You take the complement of this, chance of dying, so the chance of living is the complement of that. All right. So so now we can calculate it using L5 and L6. So we go stats, calculate, single variable statistics, enter. So now we just put in second L5, which is above the 5 conveniently, comma, second L6, which is above the 6, enter. And we hit enter. And we have the mean of minus 199.75 like we had before. And now the standard deviation is 1588, and we'll just round to that, 1588. Okay, so there's our standard deviation. All right, that's all of our examples, and I hope that's helpful to you.